Yeah, so I mean, the holy grail is taking somebody who's got established MS and giving them a treatment to, recover their function. And it's based on the hypothesis that people with MS have demyelinated axons, and you can repair those axons by remyelinating them. I think that's kind of naive because, people with more advanced disease, when they've lost their axons, you can't remyelinate them. So I suspect there's a sweet spot, and with the oportunumab Biogen trials, we thought we could select a population that was not too early, because if they're too early, you're not going to be able to see an outcome because they don't have disability. If they're too late, they've lost too many axons and they're beyond in redemption. We're going to focus on the sweet spot in the middle. So these will be people that are got damaged axons but have got sufficient recovery mechanisms in place. And so we did target that population. But one of the things we didn't do in that population was to use endogenous mechanisms to encourage the brain or the spinal cord to recover. So although these therapies are stimulating oligodendrocytes or oligodendrocyte precursors to make myelin, the real stimulus comes from exercise or rehabilitation. And I think the main lesson I'd like to go out to people is we as an MS community are going to have to add on rehabilitation, exercise to our trial protocols to promote the biological stimulus that results in recovery while the drug's on board to enhance recovery. So I think the first lesson is we need to go back to the basics and think about how the brain recovers function. And we need to learn lessons from stroke medicine and spinal cord injury. I mean, there's no way a spinal cord injury expert would do a trial to promote recovery of function of the spinal cord after traumatic injury without including superimposed exercise or rehabilitation. So that's the first thing. The other thing is age. So I know we have some defined trials where we have certain age cutoffs. There's quite a clear drop-off with recovery, with ability to recover function as we get older. And that's not intractable. I mean, the biology of aging has now been unpacked. We kind of know that aging is linked to a biological program. So could we give therapies that rejuvenate, in other words, get rid of senescence and make these oligodendrocyte precursor oligodendrocytes youthful again, and so they will recover function. And I think going forward, we're going to have to use what we call rejuvenation therapy. So these are drugs, and the one that's been studied the best by Robin Franklin and his group in Cambridge is metformin. So this is a drug that's licensed for type 2 diabetes. It probably works by upregulating NRF2, which is the master transcription factor for cell survival, and it's redox sensitive. So it alters the biology of the cell, and it actually acts as a rejuvenation therapy. So when we go forward in trials, we're probably going to have to add on our remyelination therapies onto these rejuvenation therapies to overcome aging. And in addition to that, have exercise and rehabilitation to promote recovery. And also we need to shift our focus away just from the limbs. I mean, most of our trials use the EDSS or a derivative of the EDSS, and that's not the only thing that gets damaged in MS. What about cognition? What about vision? What about bladder bowel function? So there are lots of other things we have to incorporate into the outcome measure. And I suspect it's going to have to be personalized, because not everybody's going to have damage that's repairable in every system. So obviously somebody's predominant problem is visual, they should have a visual outcome. If somebody's predominant problem is bladder or bowel, they should have a bladder or bowel outcome. If someone's predominant problem is balance, we should have a balance outcome. Lower limb weakness, lower limb outcome. Upper limb, let's say right hand in coordination, we should have a primary outcome measure for hand function. So I think we're going to have to personalize, or at least set, have subcategories, and we should actually judge the therapy based on that particular component. There's no point in measuring the other components if they don't have disability. So there's lots to think about, and I think we have to go back to the drawing board. I think the biology is right. I don't think the therapies that have been tested are wrong. A lot of them have proof of concept behind them, showing you they do get into the central nervous system, they do promote remyelination, and they are real disease-modifying therapy contenders. I think what's letting us down is the trial design.